Hey, what's up, folks? Welcome back to another episode of 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit, and joining me every week is my brother Pedro.
Good morning, everybody. I'm Pedro's Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is where we combine 3D printing and DIY electronics to make inspirational projects. We are hanging out in the Discord chat room. If anyone would like to join us during the show, comments, banter, all the good stuff, questions, you can join us by using the invite link, adafru.it/discord.
Or over at discord.gg/Adafruit. We're hanging out in all of the chats, including YouTube, LinkedIn, Facebook, Twitch. Good morning to everybody hanging out. Quick shout outs to everybody hanging out. Over on Discord, we have Mathis, we have Mr. Certainly Bruce, we got Blitzity DIY, Liz hanging out, Andy Calloway, Jim Hendrickson. Over on the YouTube, we have Nassan, Rolves, and a couple people hanging out in the Twitch and LinkedIn. Good morning to everybody hanging out on Facebook.
Yes. We are streaming on all the channels. Shout out Restream. So I'll go through the housekeeping stuff for the morning, and then we'll get into this week's project. It's a deep dive in the Midi fighter project. So let's.
Oh yeah, it's another long one, all about Midi.
So let's see. First up, check out adafruit.com/free. Your order supports everybody in the team, Lady Ada herself, and we have some deals going on. So if you want to check those out, go to adafruit.com/free. Every order gets a free black surgical mask right now, and then orders that kind of have different tiers will get different freebies. I will skip those because that takes a little bit of time. So be sure to check out adafruit.com/free. The Adafruit jobs board is up and free. So if you are a maker looking to get some new gigs, you can check out jobs.adafruit.com. And if you're an employer and looking for some makers with some maker skills, you can post up those jobs also. It's free to do so, and it's all kind of Lamar and Phil make sure everything is, they look at all the posts, so no spam. All right. We got some newsletters. We have a newsletter that's focused on the products that get added once a week. So this was the new newsletter. It happens once a week. So you can go to adafruit.com/newsletter, check it out. This is a good way to stay on top of all the new things that get added to the Adafruit shop. And then for daily content, daily digest of content and out in the web, so you can go to adafruitdaily.com. It's a standalone site. There are several different newsletters that the team works on. We have a 3D printing one. There is a biohacking one, Python on hardware, shows a lot of CircuitPython stuff, maker business, and that's just some of them. So if you're interested in that, check out adafruitdaily.com and subscribe to the categories that you like. All right, I think I'm ready to start. All right. So we're taking a look at the Learn Guide that's in review. We're so close, near the final stages of publishing. It's so close, I can feel it. Shout out to Anne Barella, who does a lot of the copy edits and guide reviews. Once it's done with Anne, then it moves on to Lamar, and then we can publish it. So here's kind of a preview. I'll do that demo later. Of the Learn Guide. So the homepage talks about the parts that you'll need.
It's quite a bit.
Yeah, so please sign up to get notified when the parts are available. The Raspberry Pi Pico, we don't have any control over the stock, and it's kind of up in the air when we can get those back in stock, hopefully soon. And some other stuff as well, like the LED driver and the OLED display. We have the buttons in stock, that's nice. There's some ancillary things like cables, the 5-way navigation switch, panel-mounted USB cables, and we also have some sets of screws, some what would you call them? Sets of screws? Some kits, something like that, an assortment of screws. Speaking of screws, I have them all listed here. There's a good handful of them, like any build that has things that need to be panel mounted. There's a good hand of screws, and I have them broken out in a list that has categories. So like the handle and the cable, the OLED, the PCB mount probably has the most of them. So yeah, is that good? Yeah. Yeah. Is our audio okay? Yeah, is our audio okay?
Yeah.
Okay, because I can't hear any of it. All right, that's the home page, parts list. There's some prerequisite guides as well if folks are new to the Raspberry Pi Pico or new to the LED driver, which is also a GPIO expander. You can check out these 3 guides. They're dedicated for those products. If you want to go more deep into those products, you can check out the individual guides for them. So the OLED has its own guide. The LED driver and the Pico has their own guides with lots of sample code and stuff. Yeah. Okay. Should I back up and talk about the project, or does everybody know about the project already?
No, there's new people coming in, so go ahead and
cool.
do the elevator pitch spiel
I shall
on
try.
why you should build this awesome MIDI fighter with the Raspberry Pi Pico $4 microcontroller.
Cool, so this is a MIDI device. It's using arcade buttons and the Raspberry Pi Pico. The Raspberry Pi Pico has tons of GPIO. To power the LEDs, we're using a GPIO expander because we've kind of used all the pins on the Pico. The main feature about this thing is that you can change and update the MIDI notes on the fly. So there's this 5-way joystick, and this little OLED display shows these little circles that represent the buttons. And so you can use the 5-way joystick to select one of the buttons. Let's say this top one here. 47, these numbers correspond to the MIDI number, the MIDI note. You can pull up a chart to see what the MIDI notes are assigned to a MIDI number, but you can use the joystick to update the MIDI note, and you can know what button you're changing because it's blinking. So that's really sweet. Now there's some flicker. You could probably notice that. That's because it's a webcam. In RL, you don't see that. That's just a byproduct of a refresh rate of the display. That's an OLED display that's grayscaled. Cool. So you can hit enter, sort of the select. So the joystick has a 4-way up, down, left, right. Right, up, down, left, right, and then to select, you just push in, and then that's the note I'm changing. So this is kind of the edit mode, and then you want to make sure to get out of edit mode by clicking in the center again, and then that saves that. And I got some tom-toms. Sweet. So it's a MIDI device. You can plug it into any DAW or capable MIDI, another MIDI device. Like if you want to control a different MIDI device, you can do that. So it doesn't actually make the sounds. What's making the sounds is this little iPhone here. I have this this adapter here that takes the audio out and routes it into this little mixer that's coming through the Wirecast setup. But yeah, any MIDI capable software will work, like Ableton, Reason, Logic, etc. GarageBand on the iPhone. I really like this kit. It sounds so good. It's kind of got that live feel to it. Sweet. So let's talk about the case. 3D printed case. It has all the things. It's a snap fit case, so it's easy to kind of open it up. It's got these little grabber things. Here's all the wires. Lovely, colorful wires. There's the LED driver right there. It's mounted to this super crazy PCB mount. we went ahead and designed a custom PCB for the 5-way navigation switch, but we could 3D print it as well, which is what you could do. We have a file for folks that you can do that, but if you want to send this off to Oshpark or mill it yourself, we got a board file, an Eagle file, which should be able to upload to services like Oshpark. The OLED display is really awesome. It's a grayscale OLED display. It has these STEMMA QT connectors on it, which make it super easy to plug into other devices. So you got your two I2C devices, you got the LED driver and the OLED display, and then you can daisy chain those into the Pico. Yeah. All right. So we got this panel-mounted USB cable that gets mounted to this over here, and that's cool. I opened it up and I can still play it. All the grounds are wired up and shared, and this is all documented with lovely photos in the Learn Guide. Yeah, so it's a bit of a 3-piece setup. You got the cover here, and then you have this frame, and then this also comes out. You can see here, these are how the snap fits are working. We got 2 sets on each side here, 1, 2, 6 on that. And I figured I'd leave these grills here open so that you can kind of see through it, and also it reduces some print time, and it looks kind of fancy. And this little metal here thing is just to support it so it's not so flexible. I went ahead and added an extra window here just so you can see more of it. Yeah, so let me kind of put it back together, kind of lunchbox style. The handle is a 3D printed in place piece, so these hinges are all assembled already for you. And then you can use some screws and hex nuts to mount it to the side of the frame. There's a bit of an angle here. You see the way it's angled? That allows you to use the as a kickstand, the handle as a kickstand. So I'm just going to go ahead and put this back together. It's pretty chunky, like the thickness of it, which works well for all the buttons, as they are not low profile. They're kind of like the standard big O buttons. But if you have a low profile, then, well, you can fit some snacks inside, and you can have yourself a lunch box, which is cool. Maybe fit a Capri Sun with some Cheez-Its or whatever snacks you like. But yeah, I really like it as an elevated thing. Print it in whatever color. This is acrylic, but we can also 3D print this little window here. Or if you don't want one, you just don't put one there. I had it in another room, but yeah, you can laser cut. We got files to either laser cut this or CNC mill it. You can use the CAD file that we have in the Learn Guide. Yeah. This is a little rubber nub that's in, I think, silicone. It's really nice. I could have 3D printed one, but I really like the silicone, and it's something you could purchase. So I figured let's just use that. Yeah. Forgot to mention, this is a collab project with Liz Clark. Give her a shout out. She's in the chat room, I think. This is a really fun project to work on, and all of our music projects are a collab with Liz at this point, so it's really awesome. She did such a fantastic job on this GUI. It is such a cool way to kind of get this sort of feature working, and it's all written in CircuitPython, which makes it really editable and customizable. We can plug this into any computer, and the code and the libraries show up. Unlike an Arduino sort of board, if you plug in your Arduino, it doesn't know what the code is, but when you plug in a CircuitPython, you get your code and your libraries and your assets and whatever else. Like we could have used a different font. This is a built-in font that we really like, but you could use fonts and bitmaps and all sort of fun stuff. We'll take a deep dive into the code walkthrough so you can get a close look at all the awesome features. Yeah.
Yeah, you can really tell that she can actually play music because of the user experience on the way that the buttons all work, and the navigation is all intuitive. So yeah, big shout outs for that. And she's also in the chat room posting about some of her design process, like the 3D printed button holder. So get on the Discord if you want to see some of that chat or ask any questions.
Sweet. Cool.
And then I am posting the link to the STL files. People already want to print this out, so if you want to get access before the guide is released, I'll put the links to all those in all of the chats. You can start printing all these right away.
Sorry about that. I just had to fix that. I love audio. Oh, wonderful, wonderful. All right, so we did a demo. We talked about some features. Let's go ahead and dive into the builds and see how much we can get through. So yeah, like Pedro said, hopefully we'll have this released very soon. If you're watching this in the future, it's been out, so that's great. So the first one, we want to set up our Raspberry Pi Pico with CircuitPython. It's really easy to do so. We have a full page here that walks you through step-by-step how to do it. I'll just kind of say it real quick. You can get your Raspberry Pi into the bootloader mode by holding down the boot select button and plugging it into your computer with a USB cable that can do data. You want to be careful with those USB cables. There's a lot of USB cables that are charge only. They're not going to do data. And hey, we have a nice note about that. Make sure you have a USB cable that is good for data sync. That just seems to be like the 99.9% problem that we have with folks that are trying to install CircuitPython or do any type of programming on their microcontroller. Get yourself a USB cable that has data.
I think this would be like the first warning, like before you even start the project. There seems to be a lot of people who aren't musicians but want to build this. This will be their first project, so definitely we'll have to make sure that is a nice big red box around it.
Yeah, but once you're in the bootloader mode, the Raspberry Pi Pico shows up as a USB drive, and then you're going to download this UF2 file, which we have a link to, right? Right there, the big green button. You download that, and let's go ahead and take a look at the website. So this is circuitpython.org. If you click on the downloads button up here, these are all the boards, not just from Adafruit, but also from the community that can install CircuitPython. So tons and tons of hardware. We even have some other fun musical devices like the Neo Trellis. Yeah, lots of fun gaming things too as well. So there's so much CircuitPython support for boards, and it's just an endless.
Why would you use anything else?
Why would you, folks? Why? Yeah. All right, so there's the Raspberry Pi Pico, and then there's this button here that says download UF2 now, and check it out. We have the latest beta. It's always nice to kind of update your CircuitPython so you can get the latest stuff, optimizations, and all the things that get added. So that's the page that really walks you through it. And then we also have this super extra nuke UF2. If something goes really wrong with your Raspberry Pi Pico, because we've had it happen, there's an extra UF2 that you can use. But that's like, again, it's a nuke. But yeah. All right, the next thing is getting the code. Really, actually, the next thing is to getting the libraries. So because your microcontroller is a microcontroller, it doesn't have a lot of storage. So to get libraries, you really want to pick the libraries that are dedicated and necessary for this project. And this is a list of them. So in the previous page, we walk you through installing the library bundle, which if you go to where I was, the circuitpython.org, click on libraries, this big bundle here will download every single library for CircuitPython, which is awesome, but you only want to install the ones that are necessary for this project, and that's these right here in the bullet list. The bus device, display shapes, text, the Midi library, and the Midi and the register library. And also some extra ones here, Simple I/O, the SSD1327, which is the driver for the OLED, and the AW9523, which is the LED driver that's driving the LEDs. But yeah, so then this is the full code. It is available on GitHub. Check out these. You can download the zip project here, the code file itself, or check it out on GitHub if you want to contribute. You can do a pull request, I think, and yeah. But there is the code already live on GitHub page if you want to post that link. I have it in there, so you can post that. So if folks want to get it right away, get your board installed and go to town on it. Liz has it all commented. It's super easy to come in here and read the comments. If you're if you're new to programming or a beginner programmer like I am, you can the comments really help a lot to decipher what's going on. Yeah, and then at the bottom here we have a nice screenshot that gives you an idea of what your CircuitPython USB drive should look like, right? So you got your code file. There's some hidden things here, I think, in Windows or Linux, but here's the library folder. You want to drop all of those libraries inside of a lib folder, and that's where your libraries live. If they're not in the lib folder, the program won't know that you have libraries. So just stuff them in there, and this gives you a good visual as to kind of review, hey, does your CircuitPython drive look like this? It should. All right. On to the code walkthrough. This one really breaks down all the segments. So the first bit is importing the libraries. Here we have all the libraries listed, setting up Midi and the I2C. Bus is all set up through here. The display setup is all set up as well. It says, so the circles and the text, the circles and the rectangles are all drawn with the display shapes library, which is really cool. So there's no bitmaps for these shapes. They're just kind of drawn in code, which is really awesome. It's nice and optimized, and it loads really fast. So yeah, so this walks through setting up the display shapes, like the circles and their spots here with their coordinates and their labels. The Midi note labels here, these can be updated if you want to change the kind of default Midi notes. It goes from 60 all the way to 75, but you can change those here because these are the labels in the circles themselves, and then we'll look at the Midi notes in the later down. The secondary menu is focusing on the edit mode, where you're editing. You get like a big circle that shows up. There you go. Big splash is the name of that one. This one walks through the pins, assigning the pins for the LEDs. So if you want to change them, you can, but they're chronological, so it goes from 0 to 15, total 16. Yeah. And then here are the note pins. So your arcade buttons, they're also chronological. We're just skipping GP15 because that's dedicated for the boot select button, I suppose. Or maybe something else, but just don't use that button. Don't use GP15. So just skip that, and the rest are listed there for you. Yeah. The 5-way navigation switch. Depending on the way you're orienting the switch, it'll change, like up is down and down is up. So you could change these if you'd like, but the guide will walk you through.
Is there like a notch or some sort of marking on the
There
switch?
is, but depending on the supplier, maybe that notch doesn't necessarily mean it's ground.
Gotcha.
So I have the schematic that we'll take a look at. Yeah, state machines. There's a couple states here. The GUI setup, the Midi notes. This is a good one to highlight here. So if you do want to change the stock Midi assigned numbers, notes, you can change them in this area of the code. It starts with 60 through 75. If you do change those, just make sure you also change up here the labels for the actual GUI. So you just want to make sure those are updated. Yeah. But the whole point is to be able to change them on the fly, right? So, yeah. There's some switch to bouncing so that we don't forever, mistake an input. So that's what the switch to bouncing is there for. Here's the actual MIDI input stuff. Very nice. If you have more, you can change the range number here from 16 to whatever you have. If you can tie multiple GPIOs together, GPIO expanders. And then there's some more stuff about the GUI navigation. Scrolling up, down, left, right, X and Y positions. So definitely take a moment to walk through the whole thing. There's so much. It's awesome. Every little piece is broken out for folks. So if you're new or a novice, you can take a look and get all the info. Next up, circuit diagram. So once you have all the code uploaded to your Pico, it's time to start wiring up some stuff. So we put together this circuit diagram. There's a lot of wired connections, so we figured it'd be nice to color code them and to kind of break them out. So that way you can kind of decipher them because they're color coded.
Using every palette.
Every palette of the color, yeah, lots of rainbow color. So sweet. Yeah, and we suggest soldering from the bottom of the PCB. That's really nice because you got labels on the bottom. The labels are not on top. They're actually on the bottom of the PCB, and they help you figure stuff out. I don't know what else to say. But yeah, normally we put this together with fritzing. I put this together in Photoshop, but you can use Adafruit's library if you want to create some real nice wiring diagrams. Fritzing is a free piece of software that can do wiring diagrams, PCBs, you name it. So check it out. Open source. And then for accessibility purposes, we break out and list out all the connections here. So all the buttons and switches, LEDs, they're all kind of telling you what GPIO numbers to use. Yes, yes. All right. On to the 3D printing. This is where you can download stuff. I have a Fusion 360 share link, which that allows you to preview the CAD design in the browser, and you can navigate around it and see all the different parts that are modeled in it. The CAD source features the original timeline. It's a parametric model designed in Fusion 360. It uses user parameters, which allows you to quickly adjust things like the spacing of the buttons, the diameter of the holes, the wall thickness, the sizes of the snaps, all sorts of fun stuff that I think folks will want to customize if it's not quite fitting, or they want a thicker build or something. You have complete control over that. Let's see. The step files, if you are wanting to use a different CAD package like Rhino or what's the other one? SolidWorks.
OpenSCAD.
I don't think OpenSCAD can do step. Whatever 3D modeler that can open step file, it's sort of a more open format than Fusion 360, because you can only open it in Fusion 360, right? But if folks just want to download the STLs, I have those as a zip file so folks can download that. So 3 different ways to get the CAD files. When it comes to that little window, it's really like meant to be personalized. So if you want to add your own text to it, or create your own, or put some decals on it, make it yours is kind of the thing there. I played around with different colors of acrylic, different things to etch or engrave into it. So I have 2 available. So one that has like the Midi logo on it, and then one that's just like a blank window. So hopefully that's good enough. It gets installed by press fitting it into the cutout. You want to do this right after you've printed the thing. So in order of operations, you definitely want to install your stuff first here. And it just press fits in. It should have a tight fit. If it doesn't, if it's too loose, you're going to want to add some super glue or some hot glue to hold it in place. Yeah. Because tolerances are tough to get. I'll print something on my print on the Ultimaker. It's got nice and tight tolerances, and I'll print it on the Creality, and it's loose.
I'll reprint an exact same file that was still on the printer, and it's completely different somehow.
It's
like, how did this change? It's the exact same file. I didn't change anything.
Yeah, it's the world of tolerances. So the next thing is to secure the 3D printed handle to the frame with these hex nuts and these M3 screws. Before doing so, though, this photo here kind of is a visual indicator, like what's the right orientation, because it's kind of symmetrical. You can install it the wrong way. You know what I'm saying? So like you want to make sure that like this cutout here for the USB extension cable is lined up with this angle here on the kickstand, so it's actually elevated. Otherwise, if it's the other way around, it's not gonna fit well. So there's that. Using these hex nuts to secure it down. They are lock nuts, right? They have that nylon insert, so they're not going to unfasten themselves. Yeah. And then once that handle's installed with the frame, it's easy to snap fit the bottom cover. And I also have a layer by layer here on how I designed the print-in-place handle, kind of from scratch, from start to finish, in this tutorial. It's about a half hour long, so if you want to get some insights into how to use Fusion 360, this is a good one if you're a first timer and if you're interested in learning. So I got that there for you. All right, next up, onto the PCB mount assembly. So I'll kind of run through these a little bit quicker because there's a lot, but they are definitely thorough. List of screws for this PCB mount. This one uses all the sizes, M3, M2.5, and M2. Sorry. If I was designing all the boards, I'd make them all M3, but I'm not, so we have to use them all M3, M25, and then 2. Woo. So this just walks you through installing them and making sure that they're in the right orientations. Cool. Wiring up the 5-way navigation switch is sort of the first thing I want folks to do. So we have a download link here for the PCB files. Figure out how you want to go about it. Do you want to just print the PCB? That's totally fine. If you want to mill it, you can do that. Or you can send it off to a service like Oshpark to have a nice silk screen and through-hole plating, which is what I have here. Here's a photo of like installing the 5-way switch into the PCB. Those little legs there that are exposed, that's where you want to solder your wires to. And we have a little screenshot here of the schematics. So you can click on to enlarge this. So if you want to make that larger, just click on it. And you can get a better, this is just ripped from the data sheet of the switch. But you can see here 1 is A, and then 4 is common, and then pin 6 over here is the center switch. Yeah, so you can use this to kind of reference, because it's a little bit difficult with the printed PCB to know what pin is what. So that's why I have that there, and you can also download the schematic as a PDF if you want to enlarge it. So that's what I have here. I figured that'd be nice for folks. But you have the PCB, you got silk screen, you got labels right on it, so that makes it really easy. Let me back up a little bit. I recommend using, we have this ribbon wire that is silicone, right? Silicone covered, so it's super heat resistant. I really recommend using all silicone wires here because there's a lot of close range soldering, and like there's times where like you get pretty close to another adjacent wire, and like if it's just regular PVC coated wire, you're gonna melt it.
Yeah, even the heat will melt it.
Even just looking at it with your eyes will melt. They'll melt the wire. So I really suggest using this ribbon cable. We have it linked in the other thing, but I also wanted to call a shout out to this lovely photo and this wire spool carousel. So we have all the colors of wire here, and you can use, this is 30 gauge wire. It's pretty thin, it's good for switches. It's not gonna pass a lot of current, but we're just doing switches here. So the 30 gauge wire, you can pick all the different colors. And I recommend getting it in a spool. We also sell them as like these little like rolls of them, like 2 meter long, but I say don't do that. Get the spool. Do yourself a favor. Get the spool, maybe print this little caddy as well, because that's fun. I like my wires. Okay. All right, so that's a little bit different. So let me go back to the wires, because there is the 10 wire. So if you type in 10 wire, this is my go-to wire when it comes to any type of thing that needs more than 3 wires. I go to this. This has 10 wires that are all bundled together in a ribbon, and they are silicone cover. So that means they're super flexible and reliable. You can peel them apart like cheese string, which is nice. So that's what I suggest using for the 5-way. There's 6 wires in this thing, in the navigation switch. That's one way to keep your wiring bundled and neat, is to use that 10 wire ribbon cable. Wonderful. All right, so we soldered that up to the Pico in the back there. Next up, we'll do the stemma cables. So we have some stable cables. You'll want to cut off the male header pins on that one and just like kind of tin them up. That way you can solder them to the back of the Pico. And that's what we got there. Installing the buttons is next up. I have a little bit of an issue here with the Learn Guide, so I'm going to go into edit mode if I can. Yeah, but this is the photos here. Installing the panel and panel mounting the buttons, all 16 of them. They all come with a hex nut that's plastic and has like a little bit of a grip on it, so that it can be tightly secured to the top cover. And then this right here gives you a good visual indicator of how the buttons are ordered, and by adding these little number labels to them. So because we are working on it from the bottom side, it's reversed. So it goes from the top right to left, and then the next row skips down, and then right to left, and then that's how we're doing it. So when you flip it over, it's actually going from left to right. So yeah, you have to just be very cautious of what button number. So I think this photo will help folks. And the circuit diagram is this way too. So you can use both to make sure that you're soldering the right number to the right pin. Okay. All right. The wiring grounds is its own thing. It's its own page because there's probably the most amount of time I spent building it was wiring up the grounds. It took me a day because of building. But I recommend like creating a bunch of short wires, 70 millimeters long, 32 of them. That's fun. 32 of the 32 of the grounds. And then the next thing I suggest is like adding a little bit of solder to all the terminals on the buttons. Be careful, you can melt them. I know I did at least 1 or 2 buttons I melted. They still work. You just melt them a little bit. Whoops. So the technique here is really to solder 2 wires at a time. I suggest using tweezers. You get finer control that way. So yeah, tweezers is a good tip, but you want to do 2 wires per ground and then just jumping each one. So in this photo series, how the first row looks, the second row, the third row, you just keep adding. You keep adding another 2 wires to each ground pin. And we wire to town. Near the end, we jump to the LEDs. So the LEDs have their own pins, and they're right outside of the grayish box. The little grayish box is the switch, and the pins that are outside of that grayish box are the LEDs. And some of the LEDs have markings on them, some of them don't. Just reference the circuit diagram, and you can know what's the cathode and what's the anode, what's voltage and what's ground. Yeah, the switch kind of doesn't matter, right? But like I like to keep it consistent, so just keep it the same. Great, and then this photo shows how all the LEDs are kind of snaking back, going from left to right and right to left, or whichever way it is. So yeah, those are some photos there. Wiring up grounds. Planing out the wires for the Pico, the LEDs and the buttons. I suggest like kind of fitting the PCB like right next to that cutout window. That way you can gauge like, well, how long does this wire need to be, and how long does this wire need to be. So that's how I was able to determine, they're going to have different wire lengths. You could do them all the same and then like cut them down later, but I recommend doing one at a time, measuring it out, cutting it, does it fit enough, and giving it a little bit of extra slack. And one of the techniques I find to kind of organize my wires, because I have a lot of them, is to use heat shrink tubing, little pieces of them, just to keep them bundled up together. This is where I'm using the color 30 gauge wire. I had it open, but not anymore. The stuff. This is where I'm using the colored wire because it helps me determine which row I'm in or which button number I'm in. So yeah, I'm using a couple different colors here. So I recommend going row by row. So 1 through 4 is the first one I'll go through. And you can see here in this photo how they're all different lengths, but they all kind of become the same length near that window area because that's where we're going to solder the wires to the Pico right there. The next row, the preceding row, so all the rows here, and this is what it looks like near the end of it. Still keeping those heat shrink tubings to keep some order there to the wires, to the chaos. All right, and then the LEDs. For the LEDs, I kind of just said, I'm going to use all red wires. That was helpful, I think. Same kind of process. They're all going to go around that area, so solder up. It's a lot easier to solder up these wires because you're not soldering 2 wires at a time. It can be a little tricky when you're soldering 2 wires to 1 pin at a time. So this one's nice and straightforward. And then after all of the buttons have wires, then it's time to wire them up into the Pico. I got the Pico secured on this 3rd helping hands. It's really nice. way to keep your PCB elevated in a spot, and you can kind of work around it. So that's what I used, but you could use a PCV vise if it fits, right? Or something else to keep it in place. Yeah, it's definitely a good thing to use. So I start off with the first row, buttons 1 through 4. Here's the GPIO pins that they get assigned to, 5 through 8. Again, another warning, don't use pin 15. It needs to be avoided. It's the boot select button. And yeah, just be cautious of the labeling on the Raspberry Pi Pico, because they kind of get squished around a little bit. So just be very cautious of that. Buttons 9 through 12, and then 13 through 16. So those are all the buttons. Sweet. Once those buttons are done, we kind of skip over to the OLED. The OLED it has these extra pins on top of the display, which is nice. I get an extra ground pin here, and because our wires were all short, it's just the right length to get soldered into the ground pin on the OLED display. So that's how I have that set up. And then this is where, before we start installing it, we want to connect those stemma connectors to the OLED display. So that's what we're doing here right before we panel mount it to the top cover with these screws and hex nuts. So I walk through installing that. If you just want to line up, you want to press the OLED over the cutout, line up those mounting holes with the tabs, insert your screw, and then in goes the hex nuts. And you just want to finger tighten those until it's nice and flush with the top surface of the top cover. Cool. Next up, we're going to install the 5-way switch. Before we do so, install that rubber nub if you have it. If you don't, it's fine too. But you want to install that before mounting it to these built-in standoffs. So the PCB, whether it's printed or a real PCB, you can use these 2 screws to secure it to these built-in standoffs that's right below the OLED display. It's pretty close proximity, so that's how it's going in there. They're really short screws too, because it's got kind of a small, short built-in standoffs. All right, then it's time to secure the Pico to the PCB mount. So I got these M2 screws. They're 4 millimeters long or 4 millimeters short, and those get installed to those M2 standoffs that we installed previously. That's why we want to set up the PCB mount kind of first, and then set it aside, and then focus on wiring. So once it's set up, you want to plug in that USB extension cable before securing the PCB mount to the top cover. Otherwise, it's like it's almost, I don't want to say impossible, but it's very, very difficult to do after it's been mounted. So you want to do this before you mount it. And that's why it's important to follow the learn guide chronologically. All right, so 4 extra screws here will secure the PCB mount to the top cover itself. Just want to press it in place, and then line up the standoff with the mounting hole, and then insert your screw and fasten away. That's what it looks like secured, and I have 2 photos here, the front and the back. So once that's set up, then we can start to wire up our LEDs. So now that our PCB is secured and our Pico is secured, let's go ahead and secure the LED driver, the AW9523. So that gets fitted over those M25 standoffs, 4 more screws. Those are the last bit of screws. Get those in there. And I just soldered it with it in place, secured. I find it fine. But if you find it's too close to the screws, you can, of course, solder your LED driver and then secure it. But yeah, I did it this way. And then I have some words here that tell you what pin goes where. There's a little note here. Be careful not to miss pin 0, right? It's on the other side of the board. I did at first. I went like, oh, pin 1 is button 1. Yeah, it starts with 0, and it's on the other side of the board. So it's a little weird, but hey, that note's there, and you can look at the photo to look at it. Yeah. 5 through 8, 9 through 12, 13 through 16. Here's another one. You want to be cautious. Pins 8 through 11 are on the other side, so it's kind of a little bit out of order, but that's just because I guess it made the routing simpler. Yeah. And yeah, the last bit you want to do is plug in that stemma cable from the OLED display into the LED driver so that they're daisy chained. Then yes, congratulations, you've completed the wiring at the end. This is what it looks like. I really like that everything is wired to the top cover, and then you just, connect it to the frame in the back cover. Cool. And then the last pages are like the final assembly, which is like, hey, panel mount that USB extension cable to the side. Choose your orientation. How do you like your USB?
Whichever way you post it, you're gonna get it wrong the first time you plug in a cable.
Well, it's the micro end, so at least it's not the Type A end, right? It's the micro end, micro B. So yeah, then just closing it up, and you're done. It's so amazing. We made it, folks. The last page is jam out. I think this video is from last week's thing, and it would show up here, but I'm in edit mode because I had some issues. But that's a quick run through of the Learn Guide. Super thorough, lots of photos, and I need some water.
Lots of great comments on this. There's some questions on having this be a Stream Deck key, and Liz points people to the Learn Guide that JP just made about the keyboards. You can map those keys to whatever macros you want.
Yep, and we also have one as well that uses arcade buttons. You can use whatever switch. Arcade buttons and tactical buttons, they're all Cherry MX buttons, they're all kind of the same, right?
And we have the question, can you play 2 of these at the same time?
Yeah.
Oh wait, no, he's asking, can you play Street Fighter 2 with it? I think so, yeah. Just not Raspberry Pi, it's just looking at whatever keys you map to the buttons.
Yeah, just make it a USB HID keyboard and assign whatever, keys you want. Yeah.
People digging the 10-wire silicone ribbon cables. Freddie saying that he had gotten rid of all of his PVC wires and replaced all of them with silicone.
Sweet.
Best upgrade. And then some discussions on fritzing being $8 now, but
yeah, that's right. It's $8 now, but it's definitely
totally worth it.
Yeah, it's definitely
especially if you like things like that. Definitely support it. And then people pointing out that you can compile it for free, so that you can still do that if you want to go that route. Some discussions on which 3D printer to get if you want to get started with this project. To fit this, it's like a 200 by 220 is the size of the frame that you want to be able to fit onto the bed. And then some Connor saying that this would be really cool as a large master PCB. So you can just plug in the...
That'd be so sweet. Yes, that is definitely what I wanted to do, but wiring is nice too.
Let's see, I think I went through all of them. Might be some that I missed. I have all the links to all of the fritzing objects, all of the code, the STL files for everything, and the rest of the guide should be posted sometime later this evening. And then shout-outs from the Bold Engineer saying thank you for the Perma Proto case that they were using on a project.
Sweet.
Speeds everything up.
Yes, I'm glad it was helpful. Well, this was so much fun to do. I wish I could do this, all the time. There will be more musical projects.
Yeah.
I'd love to see folks build it. If you do build it, let me know. You can tag me at Ekin or at Adafruit or at VideoPixel, any one of us.
We'll see it.
At BlitzCityDOI, you can tag her as well. I'd love to see folks make it theirs, add to it, add some pots. And
then there was some questions on what color PLA this is. It is the purple heat reactive PLA.
Yes. It's not blue. It's actually really purple. It's just this web camera.
Oh, wow.
It's quite fun. Right? If you look at it and you're like, that's completely the wrong color. It is.
Andy Calloway was calling it blooper?
It looks more like that. That's probably more
it is, yeah.
It is a color changing thing, so it'll
of course it's not going to change now because it's cold in here.
It's funny when I'm playing a lot and
you can kind of see it here. the heat resistance on it, or heat. Let me actually find the Amazon link to that.
When you print it, it's like pink, right?
Mm-hmm.
It kind of looks like this. That's what it looked like when it was... Wait, no, that was a different part. Sorry. Don't look at that. That's me breaking that piece, actually.
That is the silky purple.
Yeah, this
Not
is
as
silky
strong.
purple. Yeah. Oh, man, we only have 10 minutes left.
Oh, let's go ahead and jump into this week's, what are we,
Time-lapse.
prototyping?
Oh, prototype? Okay. We're just going to do the whole... We're going to extend it. Sorry, folks. So, yeah.
It's just 10 minutes because we got to eat and all that.
Yes.
So it's still working on the Guardian Egg robot from Age of Calamity.
Yeah, Zelda Age of Calamity.
Almost called it Breath of the Wild. So there is a super simple little shoulder mountable robot. Seem to be pretty popular. So there is a little servo inside of here that'll just move the head around. There'll be some LEDs in there that'll just do some little blinky. If you look inside, you can see it's the servo that we used on the fairy wings from a couple weeks ago. And everything will be fitted inside here. I'll have a NeoPixel ring inside to illuminate the eye. And then in the case on the bottom here, snap fit lid, has the little itsy bitsy inside here. We'll have the rest of the electronics and battery. I think I'll be able to fit it either inside of the lower cavity or inside of the lid part. And then the legs snap fit, and they press fit with these little ball joints to have his little feet on there. So you can have this posable, and then I've got to add the magnet on there so you can attach it to your shoulder or just have it as a desktop mountable little figurine type companion bot. So nice simple little robot here to I haven't seen many of the Guardian Egg robots. There's a couple of the one from Breath of the Wild. I've not seen many of this cute little egg robot one. All modeled inside of Fusion 360 with the what are they called? The sculpting tools inside there. So nice little way to get back into like some organic modeling.
Yeah.
So we'll have this out
of,
in I think like the week after.
Okay.
So nice little progress there on that. I got a bunch of the parts printing right now, getting some tolerances and better snap fits for the itsy bitsy there. Got the USB on there, so you can plug into that. Of course, it'll be all CircuitPython, so you can load and modify this to add like sound effects and whatever else you want to modify that with. So
Sweet.
nice, simple little companion shoulder robot. Coming up.
Yeah.
Nice.
Great. Excellent.
All right. And then quickly jumping into this week's community makes. Holy little goodie. It is this Iris Mechanical Venus box. So it's one of those little iris eyelid opening storage containers. So here is the time lapse of the main bases printing. The little lids weren't as interesting for printing. Using the rainbow silk here just so we can get a nice variation of the lids. And the tolerance on this, I think I had to lower it to like -0.2 just to get everything to glide smoothly.
All right, so let's take a look.
And went over to the overhead. Here's what it looks like. Nice, simple, well, pretty complex in terms of the modeling for this.
Yeah.
Nice little opening iris box. There's a bunch of different models available. This one was the only one I was able to get the print without too much trouble. That's why I went with this one.
Yeah.
It's a really good one by, what was it, Tom West.
Tom West. And so it's a downloadable on Thingiverse.
Yeah, this one's
Some
pretty
photos
good.
of it.
You can see how the construction for the lids, how all of those are modeled.
Yeah.
And I believe this was inspired by, it's like a remix, I believe, from one of the originals. I'm blanking out on his name.
There's
This
15
is-
remixes.
Yeah. So many.
Oh, sweet. Excellent. Yeah, very fun one. Good use of mechanical stuff.
Yep, good way to get your tolerances all in check, and you're left with this very awesome little, 3D printable mechanical toy.
Yeah.
Or storage box.
Storage, yep.
Yeah. Super cool. I like it.
Nice. All right. We do have one last community to make. This came from Twitter. This is from John R. Kelly III. Shared this really cool build of a mute button. It uses CircuitPython and a trinket. And he shouted me out because he must have looked at the Snap Fit tutorial for Fusion 360. So that's awesome. And yeah, I like the use of decals. A couple folks were asking like, how did you get the decals and stuff? So there's a nice thread here that talks about some of the details to make this nice, these nice decal graphics here for the buttons. And there's a nice switch there. And it snap fits, which is a great way to get into a case, so you don't have to use screws and sit there unscrewing everything. So that's super cool. And that's this week's community make. Thank you everybody for tagging us and stuff. Mm-hmm. And yeah.
Thanks for modifying and using all these lovely designs.
Cool. All right. Well, we're gonna say adios. It's almost that time.
Yeah.
If anyone has any other questions about anything, let us know.
Let's see, just general comments. Liz likes the leg design. Jim Hendricks saying if we scale this up 20 to 30x, it should be a really cool observatory dome shutter. Huh.
Yeah. Yeah. We thought about adding lights to it or a camera, like making it a webcam.
Yeah.
That has a servo and would like open to reveal either a light. And then we could fit this on like a panel mounted.
I did try that, yeah. It makes
on
some
a
really
pin and
cool
tilt.
effects.
It does.
It just
put a ring
blinds
in
you.
here, it adds some really cool effects. Yeah. Like the, this can still come apart, yeah?
Yeah.
Right there.
So if you take that apart, you can see where
the
little
grooves. This is how it.
What are they called?
slides in
The
and
rods slide up and down against that. It's a crazy design.
Yeah, it's really
I've seen other replacements where they have like teeth and stuff on there.
This is a good one. Some support, right?
No.
No support?
Just brin on the bottom.
Okay. Right, yeah, it's pretty thin. Yeah, the brim would definitely help.
Oh yeah.
Sweet.
Oh, cool. That's going to be it for this show. Don't forget to stay tuned later tonight.
Yes,
a whole bunch of shows, starting off with Show and Tell,
Show and
hosted
Tell.
by John Park this week.
Yes.
We'll be hosting it next week. And then immediately after that, at 8 p.m., it's a full hour of Ask an Engineer with Lamar and Phil. We'll be going over all of the news going on in the maker community, as well as all the cool new projects and products coming out at Adafruit.
You said it. All right. Tomorrow is JP's. JP has 2 shows. Tomorrow, tune in at 4 p.m. Eastern Time for John Park workshop. You can check out John building some awesome stuff. And then on Fridays, deep dive with Scott at 2 p.m. Pacific Time, which is like 5 p.m. Eastern Time. And time is changing here in the States again, unfortunately, so all that will change.
Spring forward.
Lamar had a fantastic stream on Sunday, all about mechanical keyboards, Cherry MX switches, and all that sort of stuff, and some secret stuff as well. So check that one out. It is already archived on the YouTube channel. You can check that out, but to see it live, you can tune in on Sundays at random hacker hours.
Around 9 or 10 p.m. Eastern Standard Time.
Mondays are the CircuitPython meeting, every Monday at 2 p.m. It is recorded live in the Discord server, so folks can tune into that. Or check out in the archive. We also release this as a podcast in all the different podcast services. And again, Mondays at 2 p.m. Eastern Time for the liveness. And then Tuesday is John Park's Product Pick of the Week. Get a nice in-depth look at some new products that are added every Tuesday at 4 p.m. Eastern Time. And then here we are on Wednesdays.
Yay.
It's full circle. Ba-da-ba-da-boom. It's over there, I had to reach. Well, thank you guys so much for joining us. It's been super fun. We hope to see you tonight on the Show and Tell. But until then,
Don't forget to
Make
make a great day.
bye, folks.
See you later tonight.
Whee!
Woohoo.